Hello class, what an awesome day. We're going to be learning the very last section of Module 22. Do you know what that means? That means that we're about to take a test on Module 22. And that is really exciting stuff because we get to learn what we have studied so far. So there you go. Let's first of all go ahead and copy your essential questions for you avid kids out there. How are probabilities affected when events are mutually exclusive or overlapping? I have decided to use the print version that you have as well. If you go into Google Classroom, um, that would be the second link, okay? The second link. The first one is the interactive one, and I've been using that one to record. And some of you are confused because it's different from the printed version that you have. So what I'm doing now is I'm using the second link, which is the printed version that you have. So go ahead and use that. If you need to, just for this lesson, because I don't know when is the next time I can get paper copies for you. Okay, so after this lesson, I'll go back to the interactive one. But anyhow, let's go back. Today, we're learning about mutually exclusive and overlapping events. And for those of you who are having a tough time, today is actually an easy lesson. So let's take a look. It says finding the probability of mutually exclusive events. And of course, this information is also very important, and I would like you to write this down, maybe copy it. Mutually exclusive events. Two events are mutually exclusive events if they cannot both occur in the same trial of an experiment. Basically, you might want me to translate that for you because that's too hard. It means it actually translated it here for you. You flip a coin, it cannot land heads up and tails up in the same trial. Okay, so let's see. For example, when you talk about whether you're a boy or a girl, you cannot be a boy and a girl all at the same time, right? You're either a boy or a girl. So that would be a mutually exclusive event because one doesn't affect the other. Okay, so a number of dodecahedron, I don't know if I read it correctly, but anyway, do you know what that is? It's kind of like a dice, but then it has 12 sides, okay? Because a dice is a cube, a dodecahedron has 12 sides, okay? And so each side is going to be numbered 1 through 12. What is the probability that you roll the cube and the result is an even number or a 7? This is really cool because, they draw a diagram here for you so you can just fill it out. You see, studying on your own is starting to get much easier, right? Okay. So then it says over here, let A be the event that you roll an even number. Oh, so in this circle A, you have to put even numbers. And remember, we're rolling the dodecahedron, which means that there's 12 sides. So it could be 2, 4, 6, 8, 10, and 12. Right? Okay, so you're gonna put that in A. But you know what B is? B is when you roll a 7. Okay, so in the circle B, I'm going to put a 7. In circle A, I'm going to put all these numbers. 2, 4, 6, 8, 10, and 12. And guess what? Can I put anything in the middle over here? No, not really, because guess what? There's no numbers that belong in group A that also belong in group B, because group B is just number 7, and so number 7 cannot be part of group A, right? Because A is what? Only even numbers, and 7 is not an even number. Okay, and so this is a really good example of a mutually exclusive event. In group A, there's a bunch of numbers. In group B, there's only one number, but we could have more than one number, right? But the most important thing is they have nothing in common. There's nothing in here that you can put. Okay? Everything in here is just nothing. In other words, if we were to draw it again, it's kind of like separate. A would be here and B would be here. Number 7 and 2, 4, 6, 8, 10, 12. And that's what that means. This is a mutually exclusive, okay, event. Okay? So then now it says calculate the probability of set A. What that means is the event A happening. So then if you roll that that not that dice, but that dodecahedron, you're going to have 1, 2, 3, 4, 5, 6. You could have 6 different options. So you count how many different options you have, and so you put 6 up there. And because it has 12 sides, how many sides could you potentially get? You could get 12 sides, right? So if you simplify, you get 1/2, and that would be the probability of A happening, okay? What was A anyway? That's the probability of you getting an even number. Now it says calculate the probability of you getting of B, which is you getting just a number 7, which is right here. So how many do you have there? Only 1. And potentially how many numbers can you get when you roll the dice? I mean, not the dice, dodecahedron. Yes, 12, okay? So you see how easy that is? Super easy. I think this is going to be like the easiest lesson. And then it goes a little bit forward, further, and it says calculate the probability that you can have A or B. Or means what? You can have A and you can also have B. It doesn't matter, right? So you have to include everything. So in group A, we had 6 numbers. Remember, 2, 4, 6, 8, 12. In group B, we only had 1 number, okay? So the possibility of S, that's the universal set, okay? So when you roll that dodecahedron, you could have 12 options, but when you add them together, you're gonna have 6 plus 1 is 7. So the probability of you getting even numbers or a 7 is going to be what? 7 out of how many? 12. Same thing over here. So then you have to calculate the probability of A and add the probability of B. The probability of A were even numbers, so that was 6 out of 12. And then the probability of just getting a 7 was 1 out of 12. So 6 plus 1 is 7 out of 12. So what does that mean? Oh, you just have to add these two probability, and then that would equal the probability of A or B. Okay? All right. Now let's scroll down. Again, let's look at the reflection question. How would you describe mutually exclusive events to another student? Oh, this is a really good one. I already showed you how to use the Venn diagram to assist in your explanation, right? It's kind of like group A and group B, and there's nothing in between that's the same. So you can create 2 separate circles, okay? It's kind of different from this because when you have something like that, you need to have something in common over there, okay? But the other part where it says, how would you describe mutually exclusive events to another student in your own words? Oh, I want you to go ahead and try that, okay, and see if you can do that. All right. Let's see what else. Let's keep going down. We're already on the next example. Today's homework, I noticed that you only have 1 question. Isn't that really awesome? Okay, so here's another thing that you have to copy. Now we're learning about overlapping events or inclusive events, okay? So right before this, we learned about mutually exclusive events, okay? Meaning they're completely different. Okay, the 2 events are completely different. They don't have anything in common. One doesn't affect the other. Overlapping events or inclusive events, they have 1 or more outcomes in common. Okay, so that means they have something in common. So let's look for an example, because just reading this doesn't really help you or me understand anything, right? So I'm really hoping that I'm reading this word right, dodecahedron. I should just go into the interactive side and press that play button so the guy can read it for me. But anyhow, what is the probability that you roll a number, dodecahedron cube, and the result is an even number or a number greater than 7? Oh, okay, so the question is a little bit different this time. Let's take a look. So event A is what now? Oh, it's still the same. You gotta get an even number. So set A is going to be 2, 4, 6, 8, 10, and then 12. We gotta stop at 12 because the dodecahedron only has all the way up to number 12, okay? And what is set B? B is the event that you roll a number greater than 7. So this time B has changed. B is greater than 7. So it's going to be 8, 9, 10, 11, and 12. And of course, we have to stop at 12 because there's nothing more than 12, right? Okay. So then let's see. S is the sample space. So S means what? Pretty much everything. Number 1 through 12. I'm not gonna. Okay, let me write it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, let's complete the Venn diagram. Okay, do they have anything in common between group A and group B? Let's see. Oh, look, they both have 8. Oh, they also both have 10. They also both have 12. So you see they have something in common between the A and B. What do they have in common? They had an 8 and a 10 and a 12 in common. So you're going to put that in the middle because 8, 10, and 12 can be part of group B. It could also be part of group A. Okay? But what is only part of group A? 2, 4, 6. So I'm going to put 2, 4, and 6 over here. And what is only in group 8? 9 and 11. So I'm going to put only 9 and 11 there. So if you look at this circle over here, let me see if I can highlight that for you in a weird green color. Okay, so if you look at this green circle, what do you see? 8, 9, 10, 11, 12. Because what was group B? Group B was when you roll a number greater than 7. So all of them are supposed to be in there. Now if you look at just group A, what do you have? I'm using red because, I don't know, I think red is pretty cool. Red and pink, favorite colors of mine. Okay, so there you go. And here's group A, everything. That includes the 8, 10, and 12 again. Because what was group A anyways? It was the event that you roll an even number. All the even numbers are supposed to be here. 2, 4, 6, 8, 10, 12, right? So again, 8, 10, and 12 can be both shared by group A and B. Because we have something in common in the middle, right here, the 8, 10, and 12. This is what we call an inclusive event, okay? You can go back up to check. This is what we call an inclusive event or a mutually exclusive, okay, event, okay? Mutually exclusive events or overlapping events or inclusive events. Okay, so these are all the same things that we're talking about. That is when we have something in common at the bottom as we have witnessed at the bottom right here. Right here, okay? So right here. Okay? All right. So now we can go ahead and calculate all the stuff that we just did, okay? So the probability of A was all the even numbers, right? And then B was what? Greater than 7, right? Okay, 8, 9, 10, 11, 12. Yeah, I think so. Let me go back and check because I have bad memory. What was the event of B? B is, yeah, greater than 7. So starting with 8, right? So there you go. So there you go. Even numbers were 2, 4, 6, 8, 10, 12. And so that's 1, 2, 3, 4, 5, 6 numbers. So that's 6 out of 12 total that can happen. If you simplify 6 over 12 is 1/2, right? Greater than 7 was 8, 9, 10, 11, and 12, right? And so that's 1, 2, 3, 4, 5 numbers. So that's going to be 5 out of 12. Now if you want to calculate A and B, okay? And B. That means, remember the Venn diagram we had? That means the number in the middle. Do you remember what numbers we had in the middle? Yeah, the numbers we had in common, which was 8, 10, and 12. See? They have the same numbers over there. So how many did you see there? There were 3, and there could be a total of 12 numbers you can get. Simplify top and bottom, 1 over 4. And now this time they're asking for the probability of A or B. This is a keyword. Or B means anything can happen, okay? So then, how do you calculate that? Well, you gotta go 1, 2, 3, 4, 5, 6, 7, and then you can only count 9 and 10, okay? So 1, 2, 3, 4, 5, 6, 7, and 8. You only have 8. But Miss Choi, you didn't count number 8, 10, and 12. Okay, so guys, calm down. Why do you think I didn't count 8, 10, and 12? Yes, because 8, 10, and 12 is, I already counted that here. So I don't have to count it again over there because then you're double counting, okay? So let's simplify. 8 and 12 can both be divided by 4, so it's 2 over 3. Now we're going to use all of this to calculate the probability of A or B. So let's think about this. The probability of A was 1 over 2. Sorry, my bad. Because it was right here, right? The probability of B was 5 over 12. And then the probability of A and B was 1 over 4. So then guess what? This is how you're supposed to calculate. You're supposed to add these two and then subtract that in order to get the answer. But if I put everything in the simplified form, it's difficult for you to understand when I show you the addition. So let me just keep all the denominator the same, okay? So I'm going to use 6 over 12 for the probability of A, and I'm going to use 3 over 12 for the probability of A and B. So that way you can see, when you add these two and then subtract that, you'll get this answer. Let's see. 6 over 12 plus 5 over 12 minus 2 over 12. That will be 6 plus 5 is 11. 11 minus 2 is, what have I done? Oh, okay. I'm supposed to put 3 here. Okay, and then 11 minus 3 is 8 over 12, which is the same as this answer right here. And then after you simplify, you'll get 2 over 3. So basically what the book is trying to show you right now is that there is a difference. Let's go there. So it's really important that you understand it. There is a difference of two kinds. We have a mutually exclusive, okay, event. And then you have a, oh, what was the next one that I was supposed to look at? Oh. And then you also have a overlapping or an inclusive event. Okay. And then you also have an inclusive event. The important thing that we have to know, I'm just thinking, okay, I thought what I wrote was cut off. So what they're trying to say is with the mutually exclusive event, we have two groups that are completely different. There's nothing in the middle. With an inclusive event, we know that there is something in the middle, and so both groups share something in common. Okay, and our example here was the number 7 and 2, 4, 6, 8, 10, 12. Over here it was 8, 10, 12, and then 9, 11 here, and then 2, 4, 6, 8, 10, 12, right? So that is the difference between these two. So when we want to calculate, what do we have? When we want to calculate the union, okay, oh, why did I just put the U? The probability of the union of set A and B, then because there's nothing in the middle, all we have to do is find the probability of A and then add the probability of B. Basically, you're just adding everything here, adding everything there, and then put it all over 12, and that's your answer. But when you have an inclusive event where we have something in common, okay, when we want to find the union of A and B, what that means is this is the probability that event A or B happens, okay? Then this is what you do. You have to add them together, right? So you're going to add 1, 2, 3, 4, 5, 6. And then you're going to add these over here, 1, 2, 3, 4, 5. But because you already counted the ones in the middle, when you are counting A, you're going to subtract the stuff in the middle, which is the probability of both A and B happening. And that was the intersection of set A and B. Okay? And so that is the most important thing that they were trying to teach you today. Oh, why did I say they were? That I am trying to teach you today. And that is what the textbook had for today, okay? So if you can just go ahead and draw this diagram, it will probably help you a little bit since you listened to me talk about it for a long, long time. The pictures would help you, well, the diagrams would help you, and all these other notations will probably help you. Okay, so now this is what I'm going to do. You know how I usually, when I use the interactive one, I solve the problem with you? Well, I'm not gonna do that, okay? Because over here, this is the exact same copy you have. So you only have one problem you have to solve, and it's this one right here, okay? And it says use the table to determine the probability of somebody having a headache or having no medicine. Okay, so here's the part that says no medicine. Okay, and then the person has a headache. Okay, so I want you to think about this. Okay, all the people who have a headache, and then you also have to add all the people who didn't take medicine. So these are all the people who took who has a headache and all the people who didn't take medicine. But obviously there's something overlapping, right? So I'm guessing that you'll have to take that out. And then what is it out of? It's out of 100, okay? That's the universal set. That's the only hint I'm going to give you. I'm not going to give you any more than that. But so I don't leave you in the dark, I'm going to help you with this problem right here. Okay? All right, so we have this rule that I actually wrote down for you. Or is the union that means everything. And then and is the intersection, okay? So then there you go. We're going to use the given two-way tables to determine the probabilities, okay? So the probability of senior or girl. Oh, okay, so how would you do that? What does that mean? So then you could be a senior or you could be a girl. So what's the probability that a child in a school, what is the probability that you are a girl or a senior? Okay, so that means we can count all the girls and we can count all the people who are seniors. It's not like you gotta be a girl and a senior because it says or. That's the union. So we're adding everything. We're probably using this one right here too. So let's take a look. There are many steps over here. Oh, they already explained it to you, so I should probably help you with this, but no, I'm just gonna help you with this, okay? So I will help you understand all this stuff down here. So this is all you have to do, okay? This is all you have to do. How many seniors do we have? Okay, we have seniors. How many boys are seniors? 94. How many girls are seniors? 108. So total seniors, how many do I have? So I have 202 seniors, okay? So I need to find out how many we have for all the seniors and how many we have for girls. Okay, so now I'm looking for girls. I see the girls section, and for girls, freshman girls, there's 102. Sophomore girls, there's 106. Junior girls, there's 96. Senior girls, there's 108. So how many total girls do we have? Well, we have 412 girls. Okay? So we're going to add them because we want to know the probability of a student being a senior or a girl, okay? But when we add these two, we have all the seniors and the girls. But what is our problem? This is our problem, okay? We have seniors who are also girls, okay? We have seniors who are also girls. That would be the intersection, right? So then if you're a senior and also a girl, didn't you already count the number of seniors over here? So the girls who are seniors are in here. The girls who are seniors are here too. So you basically added 108 two times. Okay, so earlier when we were counting the seniors, we already included the 108 girls who happen to be seniors. And then when we counted all the girls and put 412, we already included the 108 seniors. So we don't want to count it twice because then our numbers are going to be wrong. So we're going to subtract 108. Okay, so what do we get when we do that? Let's go ahead and quickly calculate that. And I got 506, okay? So you know what? The probability that a student is a senior or a girl, what that means is you could be a boy and a senior and they will still count you because they're looking for seniors. But if you are a boy and you're a freshman, they're not counting you because if you're a girl and you happen to be a freshman, that's okay. They're still counting you because you're a girl. You have to be either a girl or a senior. But if you're like a sophomore boy, then you're not being counted, okay? So anyhow, this is what they're looking for, the probability of all the people at the school who happens to be a senior or a girl, okay? So that would be how many? 506. There's 506 of them, and they are either seniors or a girl. But we're looking for the probability. So what is the universal set? In other words, how many students are there total in the whole school? Well, there's 808 students total. Because look, all the boys are 396. All the girls, there's 412 of them. So if you add them together, it's 808. Same thing down here. There's 200 freshmen, 210 sophomores, 196 juniors, and 202 seniors. So if you add them all together, you'll get 808 students, right? So we're going to put that over 808. Here comes the tricky part because you gotta simplify, right? So what I'm gonna do is I'm just gonna start with something easy like divide top and bottom by 4, okay? So I'm gonna use a different color. So let's say I'm going to divide the top by 4 and the bottom by 4. Then what am I going to get? Well, that's I made the wrong choice. I should not be dividing by 4, right? Okay. So then let's go ahead and divide by 2 instead. Because I have to simplify. Let's go ahead and divide by 2 instead. So then what did I get? That would be 253 over 404. Can I do anything else? 7 plus 3. I think that's it. So then my answer, the probability of any random student being a senior or a girl is what? 253 over 404. So then I feel nervous, so let me check my answer. Yay, got it right, okay. I should have looked at the answer first so I don't have to go back. But anyhow, so I want you to now let you go because I want you to try and figure this out on your own without my help. And then most importantly, I want you to figure this one out because this is your homework, okay? So I hope today's lesson went really well. In the evaluate section, you can go ahead and select any question you want to work on. But, you know, I thought maybe I'll recommend question number 1. Okay. And then, let's see, what else? And then one of these, okay? You don't have to do all of them, but maybe you can just, you know, do like number 8. Or if you want, you can do number 8 and 9, okay? It's just better if you try more because it helps you more on the test, right? And I think that's good enough. If you want to do more, that's even better. I really would like that. But if you don't want to, then again, it's all about whether you get it or not. If you get it, you don't have to solve anymore. So I just want you to know that when you come to class, this is the section you're supposed to be working on. You're supposed to be done watching my video. Then you're supposed to start solving problems in the evaluate section. And so that way, when you don't understand it, you can raise your hand and I can come and help you. You cannot ever raise your hand and say, I don't get nothing, Miss Choi. That is not okay. Then study again some more, okay? But if you have a specific question like, oh, Miss Choi, so I am stuck in this problem right here, then that's something that I could help you with, okay? So happy studying. Okay. Goodbye.